Hey MNS, so today we are going to be learning lesson 2 from chapter 4. Okay, it's a new chapter. We're at the beginning of it. We are learning to multiply fractions and whole numbers. In lesson 1, we were estimating. So we estimated how to multiply or estimate the product of fractions. Today we're finding the exact answers. So make sure you have your paper split up into the main ideas section and the notes section. And we can now begin. So first I want to talk about a little vocabulary. Let's talk about the commutative property. Might be a hard word to say, commutative. Just sound it out. So it's the commutative property. So let me read that again. So the commutative property means that operations can be performed in any order. Okay, so what this means is if we're multiplying, it doesn't matter what order we multiply in, because the commutative property says that operations can be performed in any order. So let's put some examples down. So how about 3 times 4? Okay, so we're multiplying 3 times 4. The commutative property tells us this is the same as multiplying 4 times 3. Okay, let's think about that for a second. 3 times 4 and 4 times 3. 3 times 4 is 12. 4 times 3 is 12. So no matter in what order we put them, it's the same thing and they can be performed in any order. How about addition? Does addition work? So let's see. 5 plus 6, that's the same as saying 6 plus 5. Because any way you do it, 5 plus 6 is 11, and 6 plus 5 is 11. Okay? So addition works. Now how about multiplying a fraction with a whole number, which is what we're doing today. So 1/2 times 1 is the same as 1 times 1/2. So the point is, it doesn't matter if the fraction is first or the whole number is first. Okay, commutative property tells us that we can perform this multiplication in any order. Okay, so I'm going to put a yes next to it with a smiley face, telling us that yes, we can perform multiplication, addition, and again, multiplication with fractions and whole numbers in any order. But we cannot, and I repeat, we cannot perform subtraction. So that includes 1 minus 5. We cannot do subtraction, so 1 minus 5 and 5 minus 1. These are not the same things. 1 minus 5 gives us -4. 5 minus 1 gives us 4. So they are not equal. Okay, subtraction does not work. Same with division. 8 divided by 2 and 2 divided by 8. They do not give us the same answer. So we cannot use this under the commutative property. So I'm going to put a no in all capitals and maybe a sad face. So we're going to multiply 4 times 3/5. And again, it doesn't matter if I put 3/5 first and I multiplied 3/5 times 4, it's the same thing, okay? So multiply 4 times 3/5. First, I'm going to start to multiply using an area model. So let's use an area model, okay? And when I'm using this area model, I'm going to use a bar to help me illustrate what I want to do. Okay, so here I have my bar, and I'm wondering how many pieces, how many equal parts do I divide my bar into? Well, I'll have to look at the denominator. The denominator tells me 5. So I need to divide my bar into 5 equal parts. 2, 3, 4, and 5. So 1, 2, 3, 4, 5. I have 5 equal parts because my denominator is 5. Okay, so since each of these are 5 equal parts, and I need 3/5, okay, so I'm just looking at my fraction, 3/5, and I want to illustrate it. I'm going to shade in 3 of those pieces in my bar, because that's how many pieces the numerator is telling me to shade in. So here's 1, 2, and 3. So here I have my 3/5. Okay, do you see that? 1, 2, 3 out of 5 pieces, so I have my 3/5. All right, but we need 4 of these, because this is telling us that we have 4 groups of 3/5. That means I need to make more of these. So to have 4, I'm going to copy the same thing that I did here. So now that I have all my bar graphs, so I needed to multiply 4 times 3/5, and I have 1, 2, 3, 4. Now I just need to shade in the 3/5. Okay, so I shaded in 3/5 in each bar, but I want to know how many that adds up to. Like, if I wanted to put this into an improper fraction or a mixed number, how could I do that? And I need to show it visually. So let's think of this as ice cube trays, okay? And in this ice cube tray, I have 5 available spots, and I have 3 ice cubes. So 1, 2, 3 ice cubes are filled. And I want to fill up this entire ice cube tray. So to do that, I'm just going to move ice cubes from these different trays to transport them so that I get as many whole ice cube trays as I possibly can. So I'm going to move this ice cube tray over here. Okay, so once I moved this ice cube tray over here, just shade that in, and I'm going to cross this off because I've used it. Okay, then I'm going to do the same over here. So I'm going to move this ice cube over here. So now I don't have one there, but I do have one over here. So I have 1 full ice cube tray. Okay, now I'm going to move this ice cube on over here. Okay, now that I've moved this ice cube over to this ice cube tray, I no longer have it here. Alright, and I need 1 more spot filled, so I'm going to move this ice cube tray here. So I no longer have it there. Okay, so now I have 2 full ice cubes filled, right? I have 1 and I have 2. So that's why I have my whole number 2, because I have 1 full and another full. Now, how many ice cubes do I have left in the ice cube tray? I have 2 ice cubes left. Out of how many? Well, out of 1, 2, 3, 4, 5 spots. Okay? So this is my answer. 4 times 3/5 is going to be 2 and 2/5. Okay, and I showed that visually. Now, that's one way to do it, okay? Okay, now we're actually going to solve. So when we are actually solving, we don't have to show visually what we're doing. Okay, I'm going to multiply the same thing so we can see the difference visually and just solving. 4 times 3/5. And I could even say 3/5 times 4. Remember our commutative property tells me this is the same thing, so it doesn't matter however I say it. I can say it 3/5 times 4. All right, so to solve 4 times 3/5 or 3/5 times 4, we're going to use an equation. In order to do that first, I need to show you something. So in order to know that I can solve this using an equation, okay, here's what I got to show you. So on this wall, we have invisible math. And if you take a look at this one over here, it says 3 is the same as 3/1. Okay, there is a denominator of 1 for every number. This is going to help us when we are trying to solve using an equation. Okay. All right, so what I'm going to do here, a little side note of invisible okay, what we just saw on our wall, okay? So we have whole numbers, so our whole numbers, let's say we have a whole number of 7, all right? And we want to find the fraction equivalent. Equivalent just means it's equal, the same. So we're going to, from what we saw on the invisible math wall, we're going to show how we can write 7, our whole number, as a fraction. Because remember, every whole number has a 1 under it. Okay, it has a 1 as a denominator. So here's our fraction equivalent. 7/1. All right, so I can do this with any number. If I wanted to do this with 1,285, okay, here I have 1,285. Its fraction equivalent is 1,285/1. Okay, they're the same thing. So how will that help us when we come over here? Well, we're going to use an equation to solve 3/5 times 4. So I'm going to rewrite this here. Okay, and I'm going to change how this looks. So this is equal to 3/5 times 4/1. Do you see how I changed that? Okay, I just put a 1/4. It's the same thing. All right. Now that I have my both denominators, I know what they are. Okay, I'm going to multiply across. If you've ever heard that term, it just means I'm going to multiply 3 times 4, 5 times 1. So I'm going to multiply across. Kind of highlight that there. Okay, multiplying 3 and 4 and 5 times 1. And I can change how this looks again. So I'm going to have 3 times 4 over 5 times 1. Okay, that's the same thing. Now I'm going to actually multiply them. So I'm going to have 12/5. And then the last step is to turn this improper fraction into a mixed number, which we've had a lot of practice with. Okay, so 12/5. You could draw a picture to figure this out. Okay, you could also do long division. You can also just think in your head, how many times does 5 go into 12? Well, 5 goes into 12, I think at least 2 times, right? So I have 5, 10, 15, 15 goes over. So 5 goes into 10 2 times, and then what do I have remaining? So I'm up to 5 and 10, and then I have 2 remaining, right? So I have 2 out of 5 remaining. And if you notice, this answer is the same as our answer up here. Okay, so we solved 4 times 3/5 2 different ways, so you have 2 different strategies. You have using an area model, and you have using an equation. You choose how you want to solve the practice problems moving forward.